Hello, hello. How are you guys doing? Thank you for coming. I hope you guys are less bored than I am, stuck in the house. So, did you guys get the link to watch the two videos that I posted? Well, actually, the one video I posted. Here, let me pull up the. I'll just go over it anyway. Live show. All right, so I had planned on covering this topic again on the setting up the database and going through the tables. So instead, since we weren't able to do it in person, I did the video. I hope that it's clear enough. I'm actually going to go over the video again, but let's make sure that it's clear. It's okay. You can watch it later. I recorded that way, so in case you guys have questions, you can always go back and revisit it. So let me set this up. All right. All right, cool. So, again, today's class is the intro to intro to SQL, and also with some basic on relational database. And as we previously talked about in class, a SQL is the simple query language, and there are several different SQL databases out there. MySQL is one of the largest ones. It's open source and free. I've used it for, gosh, maybe 20 years. And Oracle, I've used Oracle for commercial applications, and then Microsoft SQL is still a server as well. MySQL was bought by Oracle, so it became a part of the Oracle product line, but you can still get a free version, set it up on your web server or set it up in your home server. And there are enterprise versions with support, but you can use the free version, which is what I use now. I have it set up on my laptop, on my home servers, and I use it on the web. Most web host companies will include MySQL as a database language that's available for you. And just as a review, what is relational database? As we said, transactional data, which we used before, was a list of raw data that we can break that into pieces and save in different tables to make them make more sense as structured data. Each table contains structured information that's relevant to that table only, and then we relate one table to another using the use of keys, generally IDs, and I'll show you examples in a second. And that's why they call it relational database. So the data from different tables are interrelated through the use of keys. So a flat file database, so a one page, one table database generally look like this, right? We got each column is its own field. Field 1 could contain one kind of data, field 2, field 3, field 4. And if you're saving a personal data, field 1 could be first name, field 2 could be last name, field 3 could be email, field 4 could be date of birth, and each data row is one row of data. And spreadsheets are like that, right? So you can contain a database fully on a flat spreadsheet. But with tables, we can do something like this. That we talked about that previously as well, but this is an example of the three tables that I set up. We have transactional table on the left, we have customer table on the right top, and item table on the right bottom. As you see, I populated with some information in this table. So how do we relate each other? So you can see that the customer ID tab are now, not the tab, the column is now red. I've colored the customer ID red on both the transactional table and the color and the customer table. So what it means is that it contains basically the keys between the two tables. So the customer ID is the key to link or to relate the transactional table to the customers table. So whenever you see a same number ID in one table, it corresponds to the data in the other table. So you see that here on the screen now, we got customer ID 3 relating to customer ID 3 in the other table. So we know that for the second row of the transactional table, we're actually referring to Mary Jane because the customer IDs match. And we can do the same with the item ID. So the item ID table corresponds to the item ID column corresponds to the item ID column in the item table. So when we show a item ID 4 on that on the second row of the transaction, we really mean that it's the item ID 4 in the items table, which here corresponds to grapes, which is $2.50 per item. So you see, this way you don't have to save the information for the customer or the item in the transactional table. Rather, you can keep the transaction table small and lightweight by saving only the integer, the whole number IDs, and then refer to the other information when you need it. Sometimes we put more information in the transactional table to make it easily accessible. So maybe I want to keep the customer name in the transactional table so I don't have to pull out the name from the customer table. Those are choices that you make between making the transactional index table light versus the convenience of retrieving the data. And we can practice that in the future and see how much more difficult it is to pull in data from another table versus just keep it all in one place, or most of it in one place. So here I ask a question: show me who bought one on March 18th. So a human will go about this this way. I will look at the transaction table and find out that March 18th is the third row in the transactional table, and it carries customer ID 1 and item ID 4. Then I will look in the customer ID table and find out that customer ID 1 is John Doe and the item ID 4 is grapes. What if I want to do it in SQL? So here in SQL, I've written out a simple SQL command. Select everything. Start is a wildcard. That means everything. Select everything from transactions where date equals to 2020-0318. So then it will also, so in the SQL command, we return a third row in that transaction table like this, right? It will return customer ID is 1 and item ID is 4. Then you will go over through the links with the keys, through the relationships, go to the customer table and find out that the first customer ID 1 is really John Doe with the email of jd@abc.com. And you can go to the item table and figure out that item ID 4 is grapes at $2.50 per item. And that way you can link the tables together and you can query all the tables through the relationships. Now, you can do it in a logical sense. You can really query the transactional table first and find out what you need, and then query the other table through step 2 and step 3 like I did here. Or in the future, we can write complex queries where we query all the tables at one time. We will learn that in, I believe, next week. So you guys have any questions about this video? This video is actually saved as a video on the playlist, the 5-minute lectures for technology. So you can watch it again if you need more explanation. You can watch it again. You can watch this again too. But if you guys have questions, you can put in the put it in the chat, and I will address it. So if I see questions, I will answer it. If not, let's move over to the next thing. So the next is for us to learn how to use SQL. So I will give some simple assignments through the next video, showing what those commands are, how to use it, and what I want you to try out. So in order to try it out, I don't want you to just write out the commands and show it to me and I'll tell you if it's right or not. There's places that you can try it out, and here is one of the resources. So if you go to, the link is on the video and then on Moodle, and it's also on a video in the description of the video too. If you go to the ProfessorZ.com/SQL, XQL, theprofessorz.com/SQL, and it'll take you to this page called SQL Basics, and then links the video that you should watch, and also links a SQL Sandbox. So there's a link there, and if I click on the link, it brings me up to this page. This is the page on w3schools.com. I think I mentioned it before, but if you want to learn anything about web programming, W3 Schools is a really good resource. They have great tutorials and references, and usually a sandbox for you to try things out. So you see, this is a SQL sandbox. On the right side, you have a My Database, and they have customers, categories, employees, orders, details, orders, products, shippers, and supplies. And these are the tables with number of records in there. You see like orders, there's 196 records in there. You don't click on the restore database. That will probably take it back to the original state. We can just work around because other people use the sandbox too, so they'll put in data. We can put in our own data in and add to the database as is and select from it. But the more records, the better, because we can try different things. And you can simply type in a SQL statement in this white box over on the left side, and then click Run SQL, and it will show you the results. For example, select the very simple, the most basic SQL command. Select star, which means everything. Select everything from customers. If you click on Run SQL, and it shows, you see the table says there's 91 records over here. And here, down here, it shows all 91 records because we're indiscriminately selecting everything from customers. And it shows you the customer name, contact name, address, city, postal code, country, and these are the 91 records here. And we can get a little bit more fancy if we only want to select the customer name and address. You, instead of the wildcard, you can put in customer name, contact name from customers. And if I did this right, this will return only the customer name and the contact name. So let's click. See? So now I got 91 records, but we didn't return every column. We're only returning these two columns that I said I will return, right? And I'm going to save this for a second. Copy. And I'll change back to start. So let's say I want to select everyone from London. Let's see how many people, or UK actually. Let's see if how many people is from UK. So you can say select star from customers where country equals to UK and select. Oh, I didn't do it right. Because it's case sensitive. So UK, now we show that there's 7 records being returned from this query. So we just selected everything from customers where country equals to UK, and then let us select everyone that's put their name into UK. To be comprehensive, you really should put in or country equals to the lowercase UK, but I knew from earlier that no one was from lowercase UK, so you still get 7 results. So that's a very simple way of using SQL to query the database. You can do this with orders. So here you can see orders is set up like how we did. There's an order ID, there's a customer ID with no customer name, there's the employee ID, there's an order date, and then there's a shipper ID. And next week I will instruct you and then how to use a multi-table query to select everything from the same multiple tables at once. But right now we can just say, once we see here, and then we want to say, well, how do I find out who the customer ID is? You can then go here, either use SQL statement to search, to query the database and see who customer ID is, or you can actually go back to customers and just go down to 90 and then see it's Wilma Kala, right? So we'll go over how those commands works, but I just want to introduce to you this SQL sandbox, and we will be using this sandbox to complete the rest of the to do the rest of the semester assignment. So what I think I will do is I will do a video, show you the things that I want you to try out, give you actual statements that's based on this sandbox so you can try out and see the results. Then I'll pose a question and then you will create the queries and test it out and only submit the statements as answers once you get it working correctly. All right, so I'm looking at some of the questions. Yeah, so the email. This is what I put in the email. This is the place that we will be using to test out the things for Destiny, and I will provide further instructions on the other commands that you'll be using next week and what you need to accomplish. And then for the next question is, do you have to put in your own data? You will be putting your own data because one of the commands that right now we're only doing select, right? I showed two examples on select, which is pulling data from the database. Next week, we're going to learn select and we're going to learn insert, which is to save your own data into the database. And then we'll learn update, which is to modify the data that's already existing in the database. So with those three commands, select, update, and insert, you will be able to run your own database, save your own data, modify it some way because you can pull data back out, process it, and save it back in, and you can also update the entries. For example, on one of the earlier examples I did, there was a last visited date. So every time you visit a website or visit the app, you should update the last visited day, and that's done through using an update statement, which I'll show in next week's material. And then to answer the next question, do the statement has to be written in caps? The statement do not have to be written in caps. Let's see it. Select from. It still works. However, we like to write it in caps because it differentiates between normal English language and part of the question from the commands itself. So for the last 20 some years I've been using SQL, I know that SQL commands are not case sensitive, but it's just a habit to always write it in caps to differentiate, right? So if I write select star from select if I write it this way, then you will know select is a command, from is a command word, where is a command word, but selection might be the name of the table. It's probably not a good practice to name your table selection or something that could be confused with a keyword or with a command word. But if you write it at the very least, if you do caps or non-caps, you will know what's command and what's the table name or a variable name or a data or a piece of data. And it's also good practice also to sometimes you have to wrap data itself into quotes. So we'll show more of that in the future. The commands are not always in blue because you're only working in blue here because this box allows you to see the commands as commands, but SQL commands are just plain text words. You can use any IDE, any development environment to write the commands, or you can actually do it in text files, right? So SQL is actually accessible. SQL servers or MySQL servers can be accessible over command line. You can go to the command line, type in the command, and there it's probably better to use caps. And let me see. You give an example. Show who. Yeah, so the example I gave in the video, I said the question is show me who bought what in March 18th. So yes, the questions SQL serves to answer that question through querying in the database, right? So I would ask you a question. Show me every transaction, including customer name and what they bought and which employee sold them on in the year 1997, right? Just using an example. Then you will turn that into a command and in SQL, and you'll write out the SQL command, test it out in the sandbox, make sure that it returns you the right set of data, and then that's the answer you'll give me. So as a database administrator, as a programmer that works with SQL, that's what you do most of the time. Is business people ask you questions, and you will turn those questions into workable SQL commands. No, usually people don't look at how you run the commands, so there are multiple ways to answer that questions. I could do exactly like I said in the video. I can first query the customer database, then write another query to find out which employee it is, then write another query to find out which customer it is. But then there's 3 different queries. And when you have a large application, let's say you have 100,000 users, or let's say you have 1 million users, and you are making three queries per user, now you are querying the database 3 million times versus just writing one query that queries three tables at the same time. That's only 1 million queries. So the system will run a lot faster. So the next question, for some of the commands, there's at the end, there's a semicolon like this, where customer ID greater than 10. So sometimes we write a semicolon, sometimes we don't. So if you're writing one command at a time, you don't need a semicolon. You need the semicolon when you run multiple commands, right? So when you're programming it, if you wrote select star from customers, where customer ID equals to 10, then you write select star from items where item ID equals to 1. Now you need the semicolon, because the semicolon let the parser knows that each command is on its own line, it's its own command, so it'll run it separately. So when you're making, sometimes we stack the SQL query commands using programming that we make multiple queries at a time and under one function, then you have to construct them line by line by line, and then you separate them by semicolon. But the individual commands does not need to be semicolon. Spaces do make a difference, and parentheses also make a difference, because for example, we're going to cover that in the future too, but for example, if you were to write customer ID is greater than 1 and customer so right now I wrote select star from customers where customer ID is greater than 1 and see the connection word is command, so I'm using caps, and customer ID is greater than 99, then that should return every customer whose ID is between 2 and 89, right? But what if I want to say, or customer ID is greater than 200? So if I write it like this, there's no structure. It just says customer ID greater than 1 and customer ID smaller than 99, or customer ID is greater than 200. So it's a little confusing. So many times we'll use parentheses to kind of separate them out. So if I do it like this, then I will know that this statement is evaluated together and this statement is evaluated separately. But sometimes we write, you can change this just like very simple math, right? So if you did this, and you will yield a much different result. So we do use punctuation to structure the commands, and then some of the commands will be a lot more complicated and difficult than this. This is just a very simple command. When we start to select from multiple tables, even if just 2 tables, which we'll cover next week, then you'll have to use commas and such. And if you don't structure your statement correctly, you use punctuation incorrectly, then the result will be different. You can also perform operations within the selection and the insert within the command and the query command itself. That's more advanced. We'll cover that probably in a couple weeks before the end of April. So yeah, so this just meant to be a introduction on how to use this sandbox. So I had hoped to set up a database that we can use from scratch, but this is just as good since we're now on all together at the same place. So you can mess with this. And one of the biggest benefit of this is if you don't type it correctly, it'll just return an error. It won't crash anything. If we set up our own server, sometimes when we make really bad decisions when we write commands, it might crash the servers and cause a lot of problem. Which I've done that before at work. But and then also I think before the end of the semester, I'll talk about security a bit because there's ways to break the database or there's ways to exploit the database by writing certain inputs into commands. So if you don't know exactly, if you don't watch out for those things, hackers might be able to use, for example, like a login box to be able to try to steal passwords and steal other information from the database. So that those are advanced topics. Hopefully, I will at least introduce you to them, but just to be aware that there's a lot of validation that needs to happen. There's a lot of bad things that could happen because a business data once saved in the database, we rely on that data, right? Maybe we save payment data in there. There's definitely personal data that's in there, their addresses. Sometimes we save social security numbers and certainly passwords and email addresses. So data theft is a big thing nowadays. So if we're not careful with structuring a database and be mindful of security measures, we might compromise customer data. So I'll try to cover some of those specifically as a topic probably in 2 or 3 weeks. But anyhow, so this will basically conclude the introduction to relational database. I know you guys had some issues making sense of it before we left campus, but hopefully the last video and this session kind of help explain it a bit more so you understand a little bit more. And once we start using SQL to look for information, to query information, to save stuff in there, hopefully you will understand and then see firsthand how it works and make more sense of it. So I think I'll just leave that this week. Watch out for another video next week on the 3 commands that we're going to cover, 3 or 4 commands that it's going to cover, and then I'll do some hands-on exercises. And next Thursday at 4, we'll get back on after you guys tried it, and then I'll be able to answer some questions. And if you guys had difficulties or some of the things didn't work, I can also go over those as well. So does anyone have any questions for now? If not, then I will end this. All right, great, thank you. Yeah. So, and one housekeeping matter. You guys all got an email about pass fail for the semester, and you're welcome to take advantage of that option. I think it'll make a lot easier for everyone. So, if if you feel like you want to take advantage of it, just make sure you don't miss the deadline. I think it's April 17th. You have to put the forms in. Certainly it will make it a lot less stressful for some of you. And my office hours still Tuesday, Wednesdays, Thursdays. I can do a video conferencing or I can do phone calls, and just let me know if you have any difficulty with these assignments and things you need to do. You can save the section. You can send me the questions, or you can just come to this and put it in chat, and I'll address it on the live session. And hopefully you guys will learn something about SQL. And like I said, not too many people knows how to use SQL. And if you can learn to master this, it's such a simple thing to master. If you get the concept right and you master this language, you will be able to probably make twice as much money as a regular software developer. And it's a really good career to be able to work with data, understand it, and then no one's going to bother you, by the way. You control all the data to the business. People will be relying on you, and you're always necessary. So DBA is one of the best hats that I've ever worn. And if I had to go back to go back to tech, I'll probably work in data. Yes. I see a question. Hold on. Anyway, while I'm waiting for the question, um, so let me just say that this class is hopefully for the rest of the few weeks. It's going to be hands-on. Just try things out, and just make sure that you try things out, play around with it, and learn as much as you can on the commands. And I will, it's unfortunate that we can't be in person, but I will try to help you guys understand and then make sure that you get the concept well. Um, and Destiny, for your question, I'm not really sure. You can, why don't you send me an email, then I will give you more clear guidance on, because I don't know. And then I owe you guys an email for and then the materials for the data mining class as well. So I'm probably not gonna do video for that one. So I will send out information for you guys to study and then projects to do. All right. And all right. So let me end this here. I will talk to you guys on Thursday. And then again, have any questions? I have forums open on Moodle. You guys can also email me as well. And if we need to schedule a time to talk and that's easier, just send me an email and let me know when it's a good time to talk. Then we'll talk. All right. Have a great rest of the weekend. Hopefully you guys are staying sane and learn some SQL. All right. Have a good day. Bye bye now.